Alright, the third problem from today's weekly contest: select cells in grid with maximum score. We are given a grid and we are asked to select one value from each row, or we might even skip the row, right, if we want to. And we are asked to select a value such that you can't select that particular value again in further rows. And we want the maximum sum of those selected value as the answer. That's the problem. The first approach is the backtracking approach that we get into our mind. But sometimes there might be scenarios where we think that this can be solved greedily. But they gave us the second example to show that we can't solve it greedily, because if we try to sort the rows and get the maximum one and keep getting the maximum one, till we can. In that case, this will be 6, 7, 8, and we select 8, and the second row will be 2, 3, 8, but we can't select 8. We end up selecting 3 because of the rules of this problem, and we end up getting 8 and 3, which is wrong because we obviously can get better. That is 15. So the naive backtracking approach is the way to go, but that will give us TLE. I'm sorry. Uh, the naive backtracking approach will be on what? We'll have a used value set as a state and the row as a state, right? So we are essentially backtracking on all the values. But what if we backtrack on only the unique values? That will be, in terms of time context, will be better, because it will take care of the repeated values together, right? So how can we get the unique values? That is simple, because we have not a lot of values, so we can use a set, push each value inside that. That set will give us a sorted order of the unique values, and we can extract the values of those set inside a vector, and so that the vector contains unique values in descending order. And finally, we also need the row for each value, right? So that can be used, or done by having a map for each value. Each unique value will have a map with the row to which it belongs to. If it belongs to the same row, like 1 will belong to row 0, but it will also belong to 1, sorry, 2 to second row 3 times. But we only need once, so we'll have a set. So we'll have an unordered map of unordered set. This way I'll call num rows of each unique value. Why unique value? Because the map itself will give us, for each unique value, it won't have repeated, rows. Sorry, uh, and I'll have unordered set, not an ordered set, but a set, because I want it in order. So I'll call this unique nums set. I will traverse. I'll get the M and N. And column. Now I'll get the unique num set populated. right? And this will have grid of I and j. Along with it, I will also keep on populating num rows, and this will have the indexes as the row number. I'll get a vector called unique nums, inside which I will populate it using the set. I'll have a iterator, and I will iterate through the right side, so that will be our begin, and I will increment if the value inside this using the pointer, and then I'll call a backtracking method on this. I'll pass unique nums, the num rows, uh, the index is 0 right now. For index for iterating on over nums, unique nums, and a set to determine if the rows has been selected or not. I'm sorry about that. Let me call this use rows. This will have vector of int. I'll call this nums instead. This will be the second argument. This will be the index. This will be the selected row, so that I don't reuse a value, another value from the same row. If, what is the base condition? If index is greater than equal to nums or size, or I've used all the rows, right? This will be the case most of the time, because if all the values are repeating, only that situation will lead to this end condition. But otherwise, used rows dot size, if all of them has been used, the size will be equal to the number of rows, but that I have not passed it, so I'll pass it here. This is the number of rows. I'll call it m only. I'm sorry about that. M, then return 0. Otherwise, I will have an answer, and I will iterate. So right now I have nums of index, right, at this point, but I don't know if I can use it or not. I can only use it if that row has not been used up previously, right? So I will iterate through all of its rows to which it belongs to. All right, that is rows from map of nums of index, right? These are all the rows to which nums of index belongs to. If used rows dot find rows, then continue. Otherwise, let me make this way. All right. Uh, so yeah, if this has been not used, then I can use it. So used rows is basically getting inserted. I mean, rows is getting inserted inside used rows. I'll call the solve function again, but that will be globally tracked. I mean, the value returned from it will be globally tracked here inside answer. Nums, num rows will be as it is. Index plus 1 will be for the next element that we see. Use rows and n. But I'll also add the values, right? So nums of index is added here. Finally, I'll backtrack. Dot erase rows. I'm sorry. And yeah, what about scenarios where this happens 1 1 1 1, right? There might be scenario. I'm sorry, too much cough. I'm sorry about that. This might happen. In that case, my this will be the map will be 0 and 1. This belong to the 0th row. This belong to the first row. So 5 will belong to 0 and 1, and nums of index will have 5 only, right? Actually, nums will have 5 only. In this scenario where this happens, rows will be 0 1, isn't it? So I'll select 0. I'm saying that the scenario that when we have to skip the row, right? We can't select a row. Uh, we can't select anything from this row, right? In that case, I should skip this. So in that case, if I do it this way, no, actually, I should have a boolean value, and I should check if flag is equal to, actually not boolean, integer. If selected, then this flag will be 1. If nothing has been selected, then it's good to skip this row entirely. So if flag is equal to 0, then skip the row. Let me copy this. And finally, return answer. Right? Hope this makes sense. Actually, this will be num rows. Oh my bad. This will be dot. Let's see if this works. There's a lot of problems. Uh, mm, what is map? Oh, this should be num rows instead. Now let's see if this works. Seems to work. Let's submit it. The time complexity will be bottlenecked on the backtracking solution. So this is going to be what O of mn log mn, because the number of elements will be mn, and I'm having a set, so that will be log of mn, and this will be O of mn. Finally, this solve function is a iteration on uh, the nums, that is nothing but the unique values which can be maximum of O of mn, right? And on that, I'm having a two possible scenarios, either this or this, right? So 2 to the power mn is it. Let's see if I can see this. 2 to the power n. Alright, so this is what it is. 2 to the power m, because we are having the num rows instead, over which we are doing backtracking, and not the nums, right? That's what we have here, right? The rows for which we are doing a backtracking, and not uh, the values. That's why it's going to be 2 to the power m, and space complexity will be O of mn, O of n, right? So yeah, that's the third problem. Thanks, guys.